At Saatvik, operational excellence meets innovation in every panel we manufacture. What sets Saatvik apart is precision at scale. We don't just build panels, we build trust, backed by technology. It all begins with high-quality raw material sourced from top suppliers and checked precisely to meet stringent standards. Raw solar cells are processed in our fully automated stringer machine and are cut into half cells for better performance. The cells undergo 3 steps: slotting, laser scribing, and final cutting using water jet guided laser technology. After cell cutting, CCD inspection is performed. Good cells are automatically sent to the stringer, while NG cells are rejected and kept in the NG tray. And then automation takes over. Cells are soldered and interconnected using IR soldering with high-precision robots. Each solar cell string is precisely placed on top of a layer of encapsulant, which has been pre-positioned on the glass substrate. Each connector is measured to microns, ensuring electrical continuity and durability across the module. Soldering is done via induction technology, clean, fast, and consistent with precise measurements. High-precision mechanism locks the cell strings to protect the electrical connections, ensuring flawless performance for decades. Our barcode and branding is then pasted on the bus bar, and then EVA or EPE layers are placed over the cells along with back glass, all done in line with zero human error. Each module undergoes electroluminescence, EL inspection and visual inspection, identifying micro cracks not visible to the naked eye and any other deviations on the modules. Before lamination, specialized taping is done all around the module to ensure uniform flow. In lamination, the encapsulants are cross-linked, air removed, and then pressure is applied for a perfect seal, followed by cooling of the modules while maintaining the correct temperature. The tape is removed after lamination to keep it ready for next process. Auto trimming ensures clean module edges, critical for safe handling and uniformity. After auto edge trimming, the module is sent for frame junction box fixing and final quality testing. At the end of each shift, the nozzles are flushed and stored properly to avoid any clogging. Modules are then framed using robotic systems with uniform glue application and automatic error detection. The junction box is placed with sealant and then sealed and soldered using mutual induction, delivering reliable current flow. To maintain optimal soldering temperatures, continuous coolant flow is ensured that prevents overheating. Modules are then stored in controlled curing chambers to stabilize the structure and are strengthened using the sealant applied on the module for more than 4 hours. The junction box cap is fixed with high precision to match the speed. To eliminate sharp edges, modules are buffed for smooth, safe finishing. The robotic arm fixes the contact block automatically for delivering 24/7 testing with unrelenting speed. Each module undergoes a flash test using a sun simulator, ensuring it meets the rated power output. Electrical insulation is checked through high pot testing, followed by a final EL scan and the final visual checking. The jig is removed after testing to process further. Quality is ensured in every single module to meet customer satisfaction. Modules are then labeled, corner protected, bent as per performance, and moved to packing. High-accuracy robots place the modules in a sorter with perfection and safety. We pack with precision too. 31 mono-perk modules or 36 N-Topcon modules per box, complete with traceability sheets and handling unit. The handling units are stored in the warehouse in controlled environment with proper identification until they are loaded and dispatched to the customer. Our in-house testing facility ensures the highest reliability and durability standards in modules. Our manufacturing is built on cutting-edge automation, repeatability, and R&D-led innovation. At Saatvik, excellence isn't a phase, it's the process, perfected at every level of manufacturing. This is how we build the future of energy, one module at a time.